Hey everyone, welcome to my first YouTube video. Today we'll be exploring the MCP, the Model Context Protocol. Now you've probably been hearing about this quite a lot on Twitter or X or LinkedIn or wherever you have your tech community. And honestly, it's been the talk of, I would say, this year. Now, at first, when I first dove into this, it was very confusing. But after researching a little bit and getting an understanding on how it works, I wanted to share my learnings and knowledge, and hopefully you'll get something out of it. All right, so let's jump right into it. What exactly is MCP? MCP, or Model Context Protocol, is basically a universal connector. It sits between the AI models and a third-party APIs, simplifying how they communicate. Instead of having and building separate integrations for every single API, MCP acts as a translator or a unified middle layer. Let's visualize exactly what this means. So before diving into MCP, let's first take a quick look on how things worked before MCP. So before MCP came along, integrating AI tools like Cursor with external services like Slack, Gmail, or GitHub was a little bit messy. Each service had its own communication style, whether it be REST API, GraphQL, gRPC, and this forced the developers to build separate connections for each API, which resulted in complexity and frequent errors. Now let's see how MCP improved things. With MCP, everything is streamlined into one unified communication layer. You might wonder if adding another layer introduces extra complexity, and this is a big topic in the tech community. Technically, yes, we are adding another layer, but practically, it simplifies interactions dramatically, saving you, the developer, the time, effort, and will reduce potential errors. Now, let's take a step back and break down the main components of MCP. MCP has three essential components you should clearly understand: the host, the client, and the server. First, let's talk about the host. In the Model Context Protocol, the host serves as the environment that manages interaction with large language models. Essentially, it's the platform responsible for orchestrating communication between the client and the servers within the MCP framework. Now, in our scenario, the host is the Cursor IDE. Imagine Cursor as the organizer, setting up your workplace, managing interactions, and ensuring that the environment runs smoothly. And it can even manage multiple clients at once, which we will see later on. Now let's take a look at the second component, which is the client component. The client component is the curious part of the application. It's proactive, always reaching out to our servers. Like in our example, it's going to be a GitHub server to ask for data or perform certain actions. For example, your client might request the latest pull request or updates from GitHub. Now, in the next part, we'll see how the server component fits in, and then we'll do a deep dive into the whole communication protocol. The server component, in our scenario, the GitHub API, receives the client requests and responds accordingly. It ensures that the client gets exactly the data it requested, making sure that everything flows smoothly. Now that we know about those three main components, let's explore a little bit how MCP communication unfolds step by step, starting with establishing the connection. The first phase of MCP is establishing connection. Here, the host, in our case, Cursor IDE, initializes the client. The client then introduces itself to the server, stating clearly what it can do and asking for what the server can offer. Now, once GitHub gets that initial request, it lays out its capabilities, like a menu of what's available. Think of GitHub telling the client, here's what I can do. I can search for pull requests, track issues, fetch commits, you name it. Now, this setup ensures that both sides are on the same page, keeping the communication seamless. And with that, phase one is complete. We've established a connection, allowing information to flow in both ways. So now that we have established the connection, we move into phase two. This is where the real action happens and where the messages exchange. So let's say we need the latest information on a pull request. We ask the client to fetch their data, and then the client takes our request and sends it over to the server, kicking off the exchange. So now that the request is sent, the server, GitHub in our case, processes it and responds with exactly what we need. If we ask the latest pull request, GitHub returns the data, and then the client quickly updates our interface with fresh information. This back and forth is what keeps everything in sync, ensuring that we are always working with the latest updates. But remember, so far we've seen the client making all the requests. But remember, communication flows both ways. MCP also allows the server to take the lead. So let's see when this would happen. Let's say we want GitHub to notify us whenever a new pull request is raised and take action on it. We can set this up using webhooks, allowing GitHub to communicate directly with the client. Now, once GitHub sends the request, the client doesn't just stop there. It forwards the request to an AI model for deeper analysis. For example, GitHub might ask, "Hey, I've got a new PR. Can you review it?" The client picks up the request and sends it to the LLM. Now, this is where things get really interesting. Once the AI receives the request, it analyzes the pull request and generates insight. For example, the AI might suggest improvements, flag potential issues, or even summarize the changes for easier review. So instead of manually going through lines of code, you get an instant AI-powered feedback, making the review process faster and more efficient. So once the AI processes the request, it sends the response back to the client, which then updates GitHub with the insights. This creates a seamless automated workflow where the AI is actively enhancing development. So now that we've seen how AI integrates into the process, let's talk about how MCP handles real-time updates. Now remember, MCP isn't just about making requests. It's also about ensuring that updates are pushed instantly when they happen. For example, if a pull request gets merged, instead of a client constantly polling for updates, GitHub can immediately notify the client. The client then updates the workspace in real time, keeping everything perfectly in sync. This event-driven approach is what makes MCP so efficient, eliminating unnecessary polling and ensuring updates happen exactly when needed. Now, once all interactions are complete, the client sends a signal to the host, in our case Cursor, telling it, "Hey, we are done here." The host then ensures that everything is properly closed, freeing up resources and preventing unnecessary connections from staying open. This clean termination process is important because it keeps the system efficient. Only active connections remain open and nothing lingers at the background unnecessarily. And this is it. This is the third phase. And now that we've gone through the full life cycle of MCP, let's do a quick recap of everything we've covered. Now, to summarize everything, MCP acts as a universal connector between AI models and third-party APIs, such as GitHub, Slack, or even Gmail. Instead of juggling multiple API integrations, it streamlines everything into one unified protocol, making interactions seamless. Now, to wrap things up, MCP acts as a universal connector between AI model and external services like GitHub, Slack, or Gmail. Instead of juggling multiple API integrations, it streamlines everything into one unified protocol, making interactions seamless. So why does this matter? One, it simplifies API communication, so there is no need to handle REST, GraphQL, or RPC separately. MCP standardizes this all. Real-time updates, it pushes changes instantly, eliminating unnecessary polling. And three, it's AI-powered automation, so it lets AI interact with APIs dynamically for smarter workflows. Now let's quickly recap how MCP works step by step. So we first established a connection. In our case, Cursor IDE initialized the client, which then reached out to the GitHub server saying, "Hey, here's what I can do. What about you?" GitHub responds with its capabilities, and just like that, we had the connection set. Next, we move to the core of MCP, the message exchange. This is where the data flows both ways. The client requests information, the server responds, and sometimes the server takes the lead, asking AI for assistance. Everything stays in sync in real time, making interactions seamless. And finally, we wrap things up with determination. Once all the interactions are complete, the client signals, hey, we're done here, and the session ends cleanly, no wasted resources, and no unnecessarily connections. And that's pretty much sums it all. This is MCP in action. And that's it. That's MCP in a nutshell. I try to break it down as clearly as possible and make it easy to understand. Now, this is my first video, and I plan on making a lot more about AI front end and break it down complex topics visually. So I'd love your feedback. Was there anything I could have done better? What did you like? What didn't work for you? Drop a comment and let me know. If you found this useful, don't forget to like, subscribe, and hit the bell icon. I've got plenty more coming on AI front end and building smarter system. Thank you for watching, and I will see you on the next one.